This video delves into the details of an antique Mogul-based three-way lamp bulb, a component not commonly found in modern lighting systems. These bulbs were primarily used in older full lamps and other fixtures requiring higher wattage illumination and multiple brightness settings. The specific bulb being discussed has three distinct wattage levels: 100 watts, 200 watts, and 300 watts. This functionality allowed users to adjust the light output based on their needs, providing versatility in lighting ambience and energy consumption. Mogul base bulbs are characterized by their larger screw base compared to standard Edison base bulbs. This larger base is necessary to handle the higher current and heat generated by the higher wattage filaments. The construction of a three-way Mogul base bulb is more complex than a standard bulb. It incorporates two separate filaments, one for the 100 watt setting and another for the 200 watt setting. When both filaments are activated simultaneously, they produce the 300 watt output. The lamp socket itself must also be a three-way socket designed to switch between these different filament combinations. These sockets typically have a rotary switch that cycles through the off, 100 watt, 200 watt, and 300 watt settings. Finding a replacement for such an antique bulb can be challenging, as they are no longer widely manufactured. Firstly, check antique stores, flea markets, and online auction sites that specialize in vintage lighting components. Secondly, consider contacting lighting specialty stores that may carry rare or discontinued bulbs. Thirdly, search online retailers who deal in vintage or hard-to-find lighting products. If a direct replacement is unavailable, one might explore the possibility of retrofitting the lamp with a modern three-way socket and using a standard Edison-based three-way bulb, provided that the lamp's design allows for it safely. However, this requires careful consideration of the lamp's original design and electrical safety. When handling any electrical components, safety is paramount. Firstly, always disconnect the lamp from the power source before attempting any repairs or replacements. Secondly, ensure that the replacement bulb or socket is rated for the voltage and wattage of the lamp. Thirdly, if you are unsure about any aspect of the repair, consult a qualified electrician. Understanding the specifications of the original bulb is crucial for finding a suitable replacement or making informed decisions about retrofitting the lamp. The Mogul base is identified by its diameter, which is larger than a standard Edison base. Common Edison base sizes are E26 for North America and E27 for Europe, while Mogul bases are typically E39 or E40. The three-way functionality is determined by the number of contacts in the socket and the bulb. A standard socket has two contacts, while a three-way socket has three. The bulb itself has corresponding contacts to allow for switching between the different wattage levels. When searching for a replacement, it's important to note the voltage rating of the bulb. In North America, the standard voltage is 120 volts, while in Europe it is 220 to 240 volts. Using a bulb with the incorrect voltage can damage the lamp or create a safety hazard. The wattage of the bulb is another critical factor. Exceeding the lamp's maximum wattage rating can overheat the wiring and potentially cause a fire. It's always best to use a bulb with the same or lower wattage than the original. The color temperature of the bulb is also worth considering. This is measured in Kelvin, with lower Kelvin values producing a warm, yellowish light and higher Kelvin values producing a cool, bluish light. The choice of color temperature depends on the desired ambience and the intended use of the lamp. In addition to the electrical specifications, the physical dimensions of the bulb are also important. The replacement bulb must fit properly within the lampshade and housing. If the bulb is too large, it may not fit at all. If it is too small, it may not provide adequate illumination. The shape of the bulb can also affect the light distribution. Common bulb shapes include a shape, which is the standard pear-shaped bulb, and globe-shaped bulbs, which provide a more diffused light. The choice of bulb shape depends on the desired aesthetic and the lamp's design. When retrofitting a lamp with a modern socket, it's essential to ensure that the wiring is in good condition. Over time, the insulation on the wires can degrade, creating a risk of short circuits or electric shock. If the wiring is cracked, brittle, or otherwise damaged, it should be replaced by a qualified electrician. It's also important to use the correct gauge of wire for the lamp's wattage. Thicker wires are required for higher wattage lamps to prevent overheating. The connections between the wires and the socket should be secure and properly insulated. Loose connections can cause arcing, which can damage the socket and create a fire hazard. When installing a new socket, follow the manufacturer's instructions carefully. The socket should be securely mounted to the lamp's body and the wires should be connected to the correct terminals. It's also important to ensure that the socket is properly grounded. Grounding provides a path for stray current to flow to the ground, reducing the risk of electric shock. In older lamps, the grounding may not be present. In such cases, it may be possible to add a grounding wire by connecting it to a metal part of the lamp's body and then to a grounded electrical outlet. However, this should only be done by a qualified electrician. Maintaining antique lamps requires careful attention to detail. Regular cleaning can help to prevent dust and dirt from accumulating on the lamp's surface, which can reduce its brightness. Use a soft cloth and mild soap to clean the lamp shade and base. Avoid using harsh chemicals or abrasive cleaners, as these can damage the finish. Inspect the lamp's cord regularly for signs of wear and tear. If the cord is frayed or damaged, it should be replaced immediately. Never use a lamp with a damaged cord, as this can create a serious safety hazard. When moving an antique lamp, handle it with care to avoid damaging it. Support the lamp's base and shade to prevent them from separating. Avoid bumping the lamp against walls or other objects, as this can crack the shade or damage the base. Store antique lamps in a dry, safe place when they are not in use. Protect them from extreme temperatures and humidity, as these can damage the lamp's finish and electrical components. By following these tips, you can keep your antique lamp in good working condition for many years to come. The value of an antique lamp can vary widely depending on its age, rarity, and condition. Lamps that are in good condition and have all of their original parts are typically worth more than those that have been damaged or altered. Lamps that were made by well-known manufacturers or designers are also typically worth more. To determine the value of an antique lamp, it's best to consult with an appraiser who specializes in antique lighting. An appraiser can assess the lamp's condition, identify its maker, and provide an estimate of its value. Antique lamps can be a valuable addition to any home. They provide both light and beauty, and they can be a reminder of the past. With proper care and maintenance, an antique lamp can last for many generations. When dealing with electrical components, adherence to the National Electrical Code, or NEC, is crucial. The NEC provides guidelines for safe electrical installations and practices. For example, NEC Table 310.15. B16 specifies the allowable ampacities of insulated conductors based on their size and temperature rating. This table helps ensure that the wiring used in a lamp is adequate for the current it will carry. The NEC also provides guidelines for grounding electrical equipment. Section 250.114 outlines the requirements for grounding cord and plug-connected equipment. This section specifies which types of equipment must be grounded and how the grounding connection should be made. Additionally, the NEC addresses the installation of lighting fixtures. Section 410.16 specifies the requirements for installing lighting fixtures in various locations, such as damp or wet locations. This section helps ensure that lighting fixtures are installed safely and are protected from the elements. When working with antique lamps, it's important to be aware of these NEC requirements and to follow them carefully. This will help ensure that the lamp is safe to use and that it meets current electrical standards. Furthermore, when considering electrical modifications, specifically with older wiring systems, it is crucial to understand concepts such as voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and appliances to malfunction. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. Section 210.19. A1. Informational note number 4 recommends that the voltage drop in a branch circuit should not exceed 3%, and the total voltage drop in a feeder and branch circuit combined should not exceed 5%. To calculate voltage drop, you can use the following formula: voltage drop equals current times resistance. The resistance of a conductor depends on its material, length, and cross-sectional area. The NEC provides tables that list the resistance of various types of conductors. To minimize voltage drop, you can use larger conductors, shorter wire runs, or higher voltage systems. In the context of the antique Mogul-based three-way lamp, the voltage drop may be a concern if the lamp is located far from the electrical panel or if the wiring is undersized. In such cases, it may be necessary to upgrade the wiring or use a voltage booster to compensate for the voltage drop. Also, over time, the insulation on electrical wires can degrade, leading to a decrease in its insulation resistance. Insulation resistance is a measure of the ability of the insulation to prevent current from leaking from the conductor. A low insulation resistance indicates that the insulation is damaged or deteriorated, which can create a risk of short circuits or electric shock. To measure insulation resistance, you can use a device called a megometer, also known as a megger. A megometer applies a high voltage to the conductor and measures the amount of current that leaks through the insulation. The insulation resistance is then calculated using Ohm's law. The NEC does not specify minimum insulation resistance values for electrical wiring. However, it is generally recommended that the insulation resistance should be at least 1 megohm. If the insulation resistance is below this value, it indicates that the wiring should be replaced. This is especially important in older electrical systems, where the insulation may have deteriorated over time. The evaluation of the existing conditions and any work performed on antique lamps should always be in compliance with all applicable federal, state, and local laws, rules, regulations, codes, and standards.